Hi class, how are you? Today we are going to discuss mapping. Mapping is where we convert our ERD or EARD that we have been creating in the past two lectures in order to have relational schemas. So in other words, mapping is the actual realization of a logical design. So you can either go through the process of mapping or you can straight away do normalization. Either of the processes will give you a logical database design. So mapping, a conceptual data model is converted to a logical data model. So the tables are created which cater for the details of the entities as well as their relationships. We are going to try and see how this is done. So today we are going to discuss how do we map strong entities, how do we map weak entities, how do we map associative entities, how do we map relationships in terms of one-to-one, one-to-many, many-to-many, recursive, ternary, all those things. How do we map those different things? And then also we're going to discuss how we map attributes. In other words, how do we map simple or single attributes? How do we map multi-valued attributes? How do we map composite attributes? And then also we shall finalize by looking at how we map issues of specialization and generalization. So basically this is what we are going to do, and it's going to be a demonstrative lecture. So I'm going to be switching in between my video and also with the presentation itself. And lastly, we shall go through the demonstration. Our last lecture we created an enhanced entity relationship model of a university. So we are going to go through that, and in that case we are going to see how we map that EAR that we had last week into a logical design. So mapping a strong entity. When you're mapping a strong entity, if we go back, we said that a strong entity is an entity that exists on its own. So the existence of this entity in the database does not depend on the existence of any other entity. And in this case, you can, when you're mapping these strong entities, that means you can create schemas for them. We are going to see how we map these strong entities after I have gone through the different entities. Then we look at a weak entity. Remember, we said that a weak entity is an entity whose existence in the database depends on the existence of another entity. So, and we said that this particular entity, we have to, usually in the ER, it's represented as a dotted line. But when we are creating schemas for this particular entity, we have, or if we are trying to establish a relationship between this weak entity and its strong entity, we usually get the primary key of its strong entity, and then we concatenate it together with any other attributes of the weak entity such that you have a composite primary key. So that is what we do with a weak entity, and we're going to see how we do that. Okay, so we have this is just an example, but we're going to do our own example. You have an employee who has a dependent. So the employee type entity had these attributes, and the dependent entity had these attributes. So the dependent, this emp ID acts as a foreign key to employee to reference the employee entity. But remember, this being a weak entity, we have got to we have got to get this primary key of each strong entity, and we add it with any other of the attributes of the weak entity. Remember, you don't have a limit on how many you want to add to act as a composite primary key. You can have dependent SSN, less number, the F name, whatever, that you are not limited on whatever attributes that you want to create as a composite primary key for your weak entity. However, you need to be very careful. The more attributes you create to be part of your primary key, it kind of becomes a little hard, especially there now you're going to be creating when you create tables, and then after, at the time of populating, remember a primary key does not have to have duplicated values. So you have to be a little bit careful when you are dealing with the number of attributes that you're going to add on your composite primary key. Okay, so that's with the weak entity. We're going to do a demonstration, our own demonstration. This is also another example of a weak entity that is between a dependent who is a child. That is exactly what we did. That is what I've just explained. Now, mapping associative entities. So let's just first go and see how we map the strong entities, and then how we map the weak entities. Now, if I go back to strong entity and the weak entity, I need to, oh, hang on. I'm looking for the, okay, so here we are. We have a student. Okay, we are writing on an assumption. Remember, these are just illustrations. Sorry, these are just examples. We are writing on an assumption that a student has a dependent, or a student is also a parent, because that is very, very common. You can be a student here. We have many students who are actually parents. So this is a student who has a dependent, and this is supposed to be dotted line, because that is a weak entity. Okay, don't forget that, that's a dotted line. So to create, this is a conceptual design. Now to create a logical design out of this, we are going to, let me just do this. There's no simple way I can do it. Okay, so we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's gonna be a little long because of the many attributes that are in this particular. So I'm gonna make it a little bit small. So we have a reg number, which is our primary key. Okay. You can just write PK. But in most cases, we just underline it, okay? We just underline it, like in most cases. So we have a reg number, and then we have a 1, 2, 3, 4, 5, 6. And then we have, I'm trying to create a schema. We have a first name, and then we have a last name, and then we have a date of birth, and then we have, now, when we are logical design, at the logical design, remember, student has address, and address is a composite attribute. So in this case, we don't capture the composite attribute, but we capture the components of the composite attribute. Sorry, all these are underlined. They are not supposed to be underlined. They are not supposed to be underlined. Okay, so we capture postal code because it's a composite. So along the way, when we are discussing composite attributes, we are not going to look at this because I have already shown you how we do with it. So we have that postal code, and then we have, let me extend this a little bit. Okay. Then we have email address. It was also it was a component of the composite attribute. So we put email address, and then we have a telephone. Okay. Now, if we go back here, you see telephone is a multi-valued attribute. So when we are mapping multi-valued attribute, unfortunately, I have to introduce it now because it's already there, because if I put it there, it's going to confuse many. So when we are, because this entity called student has already a lot of things, it has a composite attribute, and then it has a multi-valued attribute. So I'm going to handle these things all together. So we have said that with the composite attribute, we capture the components of the composite attribute for that particular schema. Remember, a schema is a named relation, so don't forget to put this. This is a schema called student. You can call it a schema or a relation called student. So because it is a multi-valued attribute, we're going to handle it now because I don't want to confuse people. So multi-valued attribute, remember I said that if you have a multi-valued attribute, you pull that multi-valued attribute away from its primary entity, and then you create a new table for it. So in this, create a new table for it, and then you're going to have the primary key of the primary key of the primary relation of the mother relation being part of the primary key of a multi-valued attribute. So in this case, you will have also tel number or telephone number. So this multi-valued attribute is called telephone. Okay, telephone. Remember, please don't forget that we are trying to create, we are creating a table for the weak entity and the strong entity, but I have delved into the multi-valued attribute because this particular student already has a multi-valued attribute. That is why it has come in. So we create, for this particular multi-valued attribute, registration number is a foreign key, okay? And at the same time, it is part of the primary key. So if you look at this multi-valued attribute, there is a condition. This multi-valued attribute borrows the primary key of its mother relation, and then you concatenate it with the attribute of the multi-valued attribute, such that you have a composite primary key. So this one here is not only a primary key, but it is a foreign key. So you need to indicate that. Now this one references this one, okay? When we are looking at referencing, this references that. Oh no. This references that, okay? That's not supposed to be an arrow, so if it is there, it's there by mistake. Okay, so that the foreign key references the primary key. So that is the connection. Even at that, when we are going to implement, when we go into the actual implementation, when we are doing, when we are designing the databases and stuff, we are going to create the relationships between these relations, such that a foreign key has to reference the primary key of its mother relation. Now, there's a condition on multi-valued attribute. If the condition is this qualifies to be a primary key, a composite primary key, if this registration number cannot be unique. Okay? So in essence, this is what happens. I don't want you to cram it that the primary key of a multi-valued attribute should always be a composite primary key. That's not true. It is not true. Why? That is when I'm bringing in the condition. If this multi-valued attribute, okay, this attribute of the multi-valued attribute, if it can have unique values, in this case, it's very true because a telephone number can have unique values where each and every particular person has their own telephone number. So if this telephone number can be a unique attribute, that means we can remove registration number not to be part of the primary key, but it remains only as a foreign key, not part of the primary key. This will be part of the primary key if this telephone number cannot have unique values. For example, if I'm just giving a wild example, if telephone number, if this particular multi-valued attribute, it could be anything. For example, qualification. Okay, qualification is a multi-valued attribute because you can have a certificate of O-level, HSC, etc. So that particular multi-valued attribute called qualification, okay, cannot be unique. Why? Because any person, different people in the database can have an S4 certificate, they can have an S6 certificate. So where you have qualification here as a multi-valued attribute, inevitably this registration number has to be part of the primary key, because with the academic qualification cannot be a unique value, because many people in the database can have the same certificate like any other. But if you look at the telephone number, you can never have the same telephone number with the other person. So implying that this can qualify not to be part of the primary key, such that it is only this one being a primary key and this is just a foreign key. Please make sure that you understand that, because along the way, I'm not going to explain multi-valued attributes again, and I'm not going to explain composite attributes again. So I go back to this dependent, which we were trying to create. So we say a dependent. Remember, dependent is a weak entity. Now, when you have a weak entity, it takes the primary key of its strong entity. So in this case, we are going to have reg number, okay, which is a primary key, and then this dependent has, for example, a first name. Okay, a dependent has a first name. So a dependent having a first name, it means that we will have to add that as a primary key. I have to go back to my so let's remove this. I have to create this as a primary key. Okay. So if name, and then here we can have, let's say, last name. So that's in the conceptual. So now we bring here for us to create the schema. Okay. So we're gonna have this. I didn't even have to create it to be a primary key. It didn't have to be. Anyway, we can leave it. Okay. All right. So you have a reg number, okay, which is a primary key, and then you have a first name, and then you have a last name. Okay. So this inevitably has also got to be part of the primary key. However, registration number is also a foreign key because it has to, this has got to be a foreign key because it has got to reference student. It has got to reference student. Sorry, anyway, you get the point. So that is how it's got to be. So this particular, so that, Ctrl C, so this is an entity called dependent, okay? And then you put here. So that is the schema that is coming out of this. So we've discussed composite attributes, we have discussed the multi-valued attribute and how we deal with it. And then we have also discussed a dependent and how we deal with it. Okay, so we go back. Okay, Now we are going to look at associative entity. How do we map associative entities? There are times when you have an associative entity that does not have a unique identifier, and then also there are times when you have an associative entity that has already been, whose identifier has already been defined. So let's go back here. Again here. Okay. So here, if you look at student and course, these are many-to-many relationships. So I'm also discussing the aspect of many-to-many relationship together now, so we don't have to discuss it again. So student and course is a many-to-many relationship. Remember, we say that for many-to-many relationship, we create associative entity between the many-to-many relationship, and because I'm going to discuss how we deal with associative entities, let me first hang in there and I leave it such that we can be in position to appreciate what I am going to talk about. So when we're going to map these two again, so now we already have our relation for students. We're not going to do it again. We have already finished it. So we're not only going to create the relation called course. This relation called course has 1, 2, 3, 4. It has a course name, and it also has a course unit. Okay, so we have this into that, 3. Control C, and then we paste. I'll bring it here. So here we have our course code, and then here we have our course name, and then here we have our course unit. Okay. Course unit. Now, course code is our primary key. Now, we have said that between student and course, this is a many-to-many relationship, implying that we have got to create an associative entity. So this one is, remember that a schema is a named relation. So all your schemas have got to be named. So that is a relation called course. Now, for this particular many-to-many relationship, we are going to create a new table, which we are going to call enrolls. Interesting. Control here. It's called enrolls. As a result of this many-to-many relationship. So this particular, let me first remove this such that I can drive a point home. And then here we have a registration number. Remember that this many-to-many relationship is between the student and the course. So we need to create an associative, just like what we did last time, but this time we are creating schemas. So we need to create an associative entity. So the associative entity is enrolls. Now, if you look at this particular associative entity, it does not have a primary key. So now this is what they call an associative entity without an identifier or without a primary key. So what do? You create the primary key of this associative entity by taking the 2 primary keys of the primary tables such that you have a composite primary key. So in this case, this becomes a composite primary key. Now, this particular, I bring this one references this, okay? And this one references that. Unfortunately, the lines are crisscrossing, but please don't do that in your exams or tests or whatever. Please don't do that, okay? And these lines are not necessary. You don't have to draw the lines. I'm just doing them because I want you to appreciate what we are doing, but they are not necessary, okay? Please don't, in your exam, in your test, don't draw the lines. For us, we can be in position to know which particular table matches the other table. So don't draw the lines. Otherwise, they make the work dirty and it becomes even very hard for us to know what particular relation you're working with. So, but now this associative entity, these are just this is the composite primary key as a result of the student and course. But this has to be referenced, implying that this is a foreign key and which references course, and then also this is a foreign key which references student. So this is how you deal with an associative entity without a primary key, okay? So, or without an identifier. So where you have an associative this is the associative entity. But if you look at this, relationship here, okay, between the student and the course, okay, if you look at it critically, you realize that their attributes are the relationship type and roles. They are attributes. So what you do, if their attributes are the relationship type, you get these attributes and then you put them in the associative entity. Okay, the attributes that are sitting on the relationship type, make sure you put them in the associative entity. So in this case, we are going to get into this Ctrl C, and then we have this here, which is going to be dates, and then also we have this here, which is time. Okay, and then we put it here. So that is what happens. So now this is a complete set of tables. Depending on what you have covered, that is a complete one. So where you have an associative entity, but it already has an identifier. So now let's assume, please, I'm just assuming. Let us assume that, let's do this, and then so there is this associative entity. Sometimes scenarios can come, and then this one is the identifier of the associative entity. So if the associative entity already has an identifier that has already been stated, so what you do, these two remain as foreign keys. They are not part of the primary key. So course code will be a foreign key because it has to reference code, and then registration number will be the foreign key referencing registration number in the entity called student. So that is how we deal with associative entities, either whether they have primary keys or when they do not have primary keys. Okay, so so now we're going to see how we map attributes in our next video, part 2 video.